everyone. Thank you for joining us today for this webinar. Your presenter is Dr. Paul King, who is joining us live from Australia. Paul is the Groovy Project Lead here at Object Computing. Today in this complimentary webinar, Paul will provide us with some inside information on the release schedule and introduces the improvements and new features that you can expect, including the new parser, improved JDK 9 through 14 support, and some tooling enhancements. So with that, I will pass it over to you, Paul. Thanks.
Thanks, Jen. Welcome, everybody. Welcome to Wednesday morning in Australia. So it's I've got some birds tweeting in the background, but behind me. If you hear any funny noises, it's what I wake up to every morning. So welcome, everybody. I'm Paul King. I head up OCI's Groovy practices and also the chair of Apache Groovy PMC. The slides that I'm presenting today will be at the speaker deck URL there, Groovy Roadmap. If you go there right now, you'll get the previous version of the slides last time I gave this talk. But within 5 minutes or 10 minutes after I finish today, I'll have the new setup. And those of you most of you should be very familiar with object computing. They, as well as supporting myself doing Groovy work, they do a lot of work. Well, they head up Grails and Micronaut, which are two wonderful frameworks that make use of many Groovy features. So if you have any Groovy needs or Grails needs or Micronaut needs, certainly get in touch with object computing. As well as all things starting with GR, Groovy and Grails, and including Micronaut and so on. They have wonderful experts in a range of different areas. So there's machine learning, blockchain, IoT, cloud solutions, and so on. If you've got any particular needs in any of those areas, also get in touch. So Apache Groovy is part of the Apache Software Foundation, which has over 350 projects. So Groovy is just one of many, many projects that are within that family of projects within that big community. So please go and look at some of the other projects. And if you're interested in all things Apache, including, I'll be giving a Groovy talk there. There's an ApacheCon in Las Vegas in a few weeks' time. So please come along to that if that's of interest to you. Also, there's a new way to support Groovy. We welcome new community members who want to contribute code and want to discuss what direction the language should be in. Come and join the mailing list. But if you also want to donate a little bit of money, there's an open collective that helps support Groovy as well. So by all means, consider that if that's something that is of interest to you. We just checked, Guillaume and myself were just checking the latest download figures yesterday. The download figures for July are about 17 million or so, I think. So we're over 16 million per month of downloads at the moment. So the interest in Groovy is still very, very strong. There's been more than 250 million downloads since Groovy was first created, that's a fairly impressive figure. There's still a lot of interest in Groovy, so yeah, all that's very healthy looking. We did a recent assessment of all the activity for the project, and you can see for many of the stats, I'll just quickly show you a few of them. The project's in a pretty stable and healthy state. So this is commits across the lifespan of the project. So yes, there's a few little peaks and troughs, but on the whole, the project's got a fairly steady amount of activity across the entire lifespan. This is contributors. So there has been times in the lifespan of the Groovy project where there's been multiple people sponsored to work on it full time. We're very, very thankful for OCI to come and help me for being on the project. They're about to hit the longest period of time sponsoring the project of all the projects that have been contributing to so far. So make sure you thank any OCI members if you see them at conferences and so on. So what you can notice from this picture here is that even despite whether there's been multiple full-time sponsored people or not, there's always been quite a few contributors to the Groovy project. So you can see that, in fact, since the move to Apache, the overall trend is that there's more people contributing now than there were before. Now, some of the contributions are very small, but we even appreciate those, and we merge all those in as required. So anyway, the short summary of what that graph's telling us is that there's the contributions are still in a nice, healthy state, and things are still looking good. Issues resolved, again, fairly reasonable response most of the time. Like any project, there are times when we don't get to solve certain issues as quickly as we'd like. And there's certainly some bugs that have got fairly low numbers in the issue tracker that I'd like to see resolved that still haven't been resolved, and we're obviously working on those. But on the whole, the project's had a fairly good go at being responsive to issues. This is the looking at the releases. So again, there's fairly stable cadence across most of the lifespan of the project. There was a short glitch around 2006 when the project was trying to create a JSR, so that's an official specification of the language and a whole compatibility toolkit, and it was going to be the first official language on the JVM with a fully formal spec. That activity never finished. It was actually quite a big undertaking. But the nice thing about what came out of that was that there's now a large pool of tests that form the specification of the language that are part of the test suite. So there's no formal spec, but the spec is embodied in a bunch of tests that are part of a very, very large, over 10,000 tests in the test suite, and that's carried on throughout the life of the project. Also, another glitch 10 years later, 2016. We're expecting another glitch in 2026, perhaps. When we joined Apache have a very formalized way of doing releases. So every release gets manually checked by hand by at least 3 people on the project management committee, and they have to vote. They have to sign it off and vote on it, check that it's been properly signed by an official member of Apache and so on. And it took us a little while getting that process ironed out. So 2 little glitches there. The rest of the time, the project's had a very, very healthy release cadence. We're expecting that to continue. What does Groovy provide? It provides a whole lot of bells and whistles and enhancements, if you like, over what Java would give you. And even though it's a very, very crude measure, you can look at the number of methods that are in the GDK. So these are all the extension methods. So one extension method might add a size method to a list or a string or whatever. And so that's one method. There is some 1,800 of those in the latest GDK. So in the version 3 that is out there now, there's lots and lots of those methods. So lots and lots of enhancements in the GDK. They're available for both the dynamic mode of Groovy and the static mode. So there's those enhancements are all applicable to both the different natures that Groovy provides. And AST transforms. Some of the AST transforms are very small and add a little tweak to your code. Others are very, very large. Something like immutable adds potentially many hundreds of lines of automatically generated code to your classes in a very declarative way. So some of these extensions are very, very, very powerful, and you can see there's over 60 of those in the latest versions as well. So we're expecting to see those enhancements continue, and now that we've got modules and we're moving towards having full Java compliant modules, then we're going to have a way to manage the complexity that's and manage the releases of those that extra functionality in a slightly more useful fashion. We'll see some of that later when we look at the roadmap and the different modules. So that's sort of Groovy by the numbers, a whole bunch of different graphs. They all show that things are looking pretty good. Someone like myself would like to see more happening, but I'm sort of realistic that if we keep offering new versions of Groovy, keep putting in new features that are useful, keep working on different pain points, I think things are going really well. So let's get in and look at some more of the details. I'm going to very, very briefly look at some of the things that came out in 2.5. Not going to spend much time on that. Hopefully most of you are familiar with that. By all means, shoot more questions later, or come and speak to us in one of the forums or mailing lists if you've got more questions on 2.5. I'm going to try to spend most of the time on Groovy 3 and a little bit on what the planning we've put in place for Groovy 4 and some initial work starting in that space too. So first off, brief summary of 2.5. So what is, just a reminder of what is Groovy. It's basically Java, but only better. So we got rid of some stuff that makes you less productive, some of the boilerplate code, and we've added in a whole bunch of bells and whistles, some runtime and compile time metaprogramming, and a bunch of useful libraries, and so forth. So that's how we describe Groovy in our elevator pitch. But obviously, when we say it's Java minus some stuff and plus some other stuff, Java's evolving all the time. So as a language, every time a new release of Java comes out, we make a call. Do we want to support any new syntax that might be there? Can we automatically, and usually we often do. And the reason we stay close to Java is that what it means is whenever a new version of Java comes out, we often get a whole new range of functionality for free. So we're only a small project, and if we can piggyback off all the new things that are coming in Java, that's new functionality that all Groovy programmers can make use of, and we didn't have to engineer it. So we try to stay close to Java, but it means every time there's a new release, we've potentially got some tweaking to do. So we did some of that in 2.5, and again, I'm not going to go into all the details, but there's some of the JSRs and JEPs, Java Enhancement, I think it's protocol or proposals. We've added support for those. So that's things like repeated annotations, having method parameter names appear in the bytecode, GDK methods for all the Java time package, replacing all the Java util date and Java util calendar, which is sort of almost treated as deprecated components. So we kind of follow along with that to some degree these days. Annotations in more places. So you can have non-empty, non-null arrays of non-empty strings and things like that. So there's new features in JDK 9, different security model, different module structures and so on, making sure that Groovy at least runs, even if it's not using all of the features, at least it runs on those environments currently with a few warnings. But all of that's in place for 2.5. And we've done the initial repackaging in the 2.5 space to move towards modules, but certainly not fully module compliant. There's a updated story for 3 and 4, which I'll get to a bit later. So these are our modules. Now the ones in blue are the ones that are in Groovy 2.4 that you're probably all familiar with. In Groovy 2.5, we added a bunch of new modules. So there's an optional one there for Jaxby. Some of the stuff that will eventually not work on JDK 9 and above, like directly peeking inside JSON fields as an efficiency activity. That's in a JSON direct module. We know that's not going to work in future versions of Java, so we've made that optional, and by Groovy 3 that's actually gone. So there's a default that now sits in its place, which is very, very slightly less efficient, but doesn't have any of the issues that particular module does. So that's what people will get by default from Groovy 3 onwards. There's some new CLI stuff and so on and so forth. A new module, YAML module, coming in Groovy 3, which we'll see that a little bit later on. The CLI builder that is in Groovy 2.4 is based around common CLI. But that's still going to be there, but it's becoming optional, and most people will probably use the Pico CLI version of Groovy CLI. So that's the sort of, in terms of the overall functionality that's in Groovy, it's split into these modules, and that's how we're evolving it over time. So if we, for instance, in Groovy 4, if we make a new stream-based version of XML Slurper, then inside Groovy XML, there'll be this new version of the XML Slurper. If we have to, it could be an XML2 or something, we might have a name like that, but our current thinking is that Groovy XML will just have the new functionality, and if there's any old functionality, if it's not fully binary backward compliant, there might be a Groovy XML legacy or something module, and people who want to, if there's any particular characteristics of the old XML slurper or parser that people are particularly wanting, they can go and use the old module. So this gives us a way to move the language, evolve it without impacting users too much, or at least giving them a very clear picture of what they need to do to make use of all the functionality. So that's what's happening in the module space. AST transforms 2.5 introduced quite a few improvements. I haven't got time today to go into all of those, but just quickly look at a couple of things. Now, just a reminder, what is AST transforms? So Groovy's compile time metaprogram, it's a compile time metaprogram capability, so that allows you to change your programs, add new features and so on in a declarative way during the compilation process. So over on the left-hand half of that slide, there's a bit of code, class athlete with a couple of properties and a constructor there. Oh, no, I'm just calling it constructor. And when the compiler's compiling that code, it'll convert it into what's called an abstract syntax tree. So if we're talking about AST transforms, it's something that transforms the abstract syntax tree, the compiler's data representation of your code. And what the compiler does is it starts out and it's got a fairly anemic, so it's a not fleshed out version of all the things that are in your code. And the compiler runs through a bunch of different phases, and it adds more information in during each phase, each step of each phase, and eventually you get a fully fleshed out, rich of all type information and all the extra stuff that Groovy has added to your class. And that's what will be used to generate the bytecode that you then run. What the AST transform process does is it lets you participate in the compilation steps. So if you put @toString on the athlete class here, then that triggers the execution of a toString AST transformation, which will add a toString method into your class here. So that abstract syntax tree, the representation of your program gets augmented. There's now a toString method node, and it's slightly approximated, but it's equivalent to it if you'd gone and written that toString method in your class. So in this particular case, it's doing a toString that's using the class name followed by the properties that we know about the class. So that's the AST transform process. 2.4 had quite a large number of those. They've been evolving since 1.6. There's been started off with 10 of them, then 13, and so building over time up to the complete blue list is 2.4. 2.5 has added a whole bunch of the green ones there, and there's more in 3. So I'm not going to spend too long talking about the 2.5 ones, but I'll quickly go through those. The other thing to point out is that as well as adding the new ones, the green ones, in 2.5, a lot of the original AST transforms were revamped as well. So by revamped, here's, for instance, tuple constructor. All the blue ones were the configurability options that were available for tuple constructor. And 2.5, you can see it's got a whole bunch of additional ways to configure that AST transform. So when you performing that transform to your program, it's a declarative way of adding a design pattern or getting some boilerplate code generated. Not everyone has the same need, and so you'll configure it to, for instance, if that toString one, I may want to print out the names of the properties as well as the property values. And so there's an include names field that I could use for that and so on. So I can configure this declarative approach to augmenting my program. And so you can see a lot of the transforms were like this. They had things added, and this was done to make things consistent across all the different transforms. The other thing that we'd added into Groovy a few versions ago, but didn't make a lot of use of, was meta annotations or annotation collectors. So canonical is something you can put on your class that generates a whole bunch of things for you. In fact, it actually adds a tuple constructor. It does that toString that we talked about before. It adds equals and hash code methods as well. So conceptually, it's always the canonical transform has always logically been the same thing as the 3 individual bits of functionality. It's actually now defined in our source code as exactly that. So we can say that whenever you put @canonical on your class, in fact, it'll just replace it and put all the 3 different individual components on there. And we added that capability so that you can actually mix and match other things in here, and it gives us a much more fine-grained and better way to tweak these things. So we were getting lots of people wanting new functionality, and this allows Groovy users to have much more control over which bits they can use and how to configure things. And that's just showing you how things will work here. If I have canonical and we've got some of those annotation attributes, so I can tweak or configure how I want canonical to be applied. All of the appropriate annotation attributes will be fed to wherever they are applicable for all the individual annotations there. So you can see cache equals true has been spread over to the toString and the equals and hash code. So that would be appropriate if I've got a class where the hash code, well, I'd want a class where I'm not changing my X and Y points if they're part of the hash code. So I'd cache it would mean I'm treating this as an immutable class here. So the same principle was done for immutable, but in fact it turns out it's actually split into quite a few different pieces. And again, this allows us to actually evolve the functionality that's part of immutable in a much more fine-grained way. We were getting lots of feature requests. Oh, can you add this? Can you add that? And immutable was becoming a very bloated piece of functionality. Now it's split up into a lot of fine-grained pieces, and you can override any of those individual pieces. So if you don't like what we're provided, then you can still get most of the stuff for free. So all the different individual bits that are part of immutable there, you can get those for free and just tweak one of the little bits in there, and you can create your own tweaked version of immutable, and we don't have to offer that as part of the Groovy package. And as well as in here, I've got actually a whole bunch of Groovy AST transforms, but they could be Spring Boot annotations or some sort of marker interfaces of some other framework that I'm using. I could be using JUnit 5 annotations here and combining those with Groovy ones and so on. So there's a whole range of different things that could be part of these meta annotations. And just to give you a flavor of one thing you could do, I can go and merge in canonical. I can bring in some immutable base functionality, which that does some preliminary stuff that if you wanted immutable objects. And then I can create property options. I can create an immutable property handler here. And this would allow me to have an immutable property with just one constructor, which some dependency injection frameworks might be expecting. So if the standard immutable doesn't work for you, you can go and mix and match some of the pieces and get slightly different things that might do exactly what you need. And you can go and I could go use Guava's immutable collections or something else by doing a few little tweaks in the same sort of way. So allows us to all the wonderful functionality that we've put in there allows it to be used in more ways. Makes the language a more extensible one. Okay, so I'm not going to go through all the other AST transforms. It'll use up all of our time today, but just highlight a couple of things. One of the things that tuples constructor has is pre and post conditions. So again, there was a lot of people saying, oh, I really like tuple constructor, or I really like immutable, or I really like whatever, but I need to inject some of my own functionality into the constructor or into this or into that. And given that I can't, I have to throw away immutable or throw away tuple constructor, so I can't use it. Well, this actually allows you to tweak, put code into the constructor either at the start with the pre or at the end of the constructor with the post. So again, it gives you a very, very nice way to in a fine-grained fashion to configure and tweak these. Here's how we can create a constructor that's private. So we might have our own factory method, make person, and we'll go and put a private tuple constructor onto the person class, which we making use of inside our make person factory method there. So again, a lot of things that people were asking us, can you put a make private equals true annotation attribute on tuple constructor? Well, we didn't want to bloat out all of our annotations, so there's now some common ways to configure things, and so visibility options is one of those, and it's quite flexible. Okay, map constructor. Groovy has a way of emulating named arguments as if it was a map-based constructor. But if you want to have full configurability over that, then you've now got a map constructor annotation that you can tweak. There's an auto implement. So Groovy's had very, very powerful ways to create dummy objects for tests. So you could, for instance, create a map which has a closure false, a closure returning false that's the value associated with the key has next. And just by going as iterator, that becomes a dummy iterator object that I could put into a test class to find out what happens if I'm ever given an empty iterator. How is my code going to behave? That's a very, very dynamic way of building a dummy object without having to write a whole class. You can now do that with an auto implement. So Groovy's got both this dynamic and static natures, and we've often put in functionality into Groovy for doing things in a very dynamic way, like memoizing or, in this case, creating dummy objects. We've rounded out the language, so there's typically a static way of doing nearly all the same things that you can do using the dynamic capabilities of Groovy. So if you're moving your code base to wanting to use static things everywhere, perhaps you have a high level of integration with a Java project and you need to make those things available, then you'll have options in which you can do that now. So auto implement there will fill in, give you dummy versions of all the methods that are in any interfaces that of your class, or any abstract methods that are in any base classes. It'll give you dummy implementations of those, and there's ways to tweak it to throw unsupported operation exceptions or do other things instead of just returning null and so on in those dummy methods. So it's configurable. There's an auto final that puts final in a bunch of different places there. So you might think auto final there is almost as much number of characters as putting final keyword into the code there. But think of this in terms of those meta annotations. You can make your own immutable class with final everywhere just by merging that auto final into a meta annotation. So you might mix in a bit of Spring Boot, an auto final, a canonical, and mix all those things in and as you're creating your classes. Now, name variant is another interesting one. So Groovy's, again, always had a special trick where you could use a map as the type of your arguments, and you could use named arguments. And we'll see that on the next slide. So this is the map version here. And I can go color, colon, red, size, colon, 20. But let's come back to the original code. So this would be the typical Java way of creating, in this case, a choose box method. So this is, you're at the checkout of a shopping cart, Amazon or something, and you're wanting to gift wrap the item that you've just bought. And so this choose box is going to decide, do you want a special box, a large box, whatever, to wrap your gift in. And the choose box method, we can specify color of the box and we can specify the size. And they're strongly typed parameters for there. But if we specify them in that way, then we have to actually call the choose box method in the normal tuple fashion. So we're calling choose boxes red and 20 and so on. The Groovy trick would, if you have a map-based method, then I can actually use the color, colon, red, size, colon, 20. Then the order doesn't matter. Doing defaults is slightly nicer. If I've got 20 of these parameters and I'm only interested in tweaking 2 of them, instead of having this big long tuple with a whole lot of values that I'm not interested in, it'll just be the things I'm interested in that you'll see when you're calling the method. So there's lots of nice properties of using this particular style, but there's a downside as well. And the downside is that for both the writer of that choose box method, who's using the map, and also the user of the choose box method, if they now start wanting to use the static nature of Groovy and turn on all the type checking everywhere, the fact that they're using a map there, and the best we can do to cater for arbitrary situations is a map from string to object. Type checking will let slip through quite a few different errors here, simply because the typing information is not in the map. So the map doesn't have that information. So map, if I've got red, a special box is one where the color is red, and I've misspelt color here. I've used typical UK or Australian OUR, and the code is expecting just OR, the typical American variant of that spelling. That'll just silently fail. Type checking will say, yes, everything's correct, and it'll just fail because it's just a string, and the string will just never be in the map. Well, in fact, it is in my map because I've actually got the misspelling in a second spot as well, but let's ignore that for now. And the user of this particular map method as well, they might do the same misspelling. They might specify the size as a string instead of a number. And they'll again, type checking will say, yes, everything's fine, but then you'll get a Groovy cast exception at runtime. So yes, using this map style was a nice feature to get sort of very fluent and nice looking ways to call my method, but I've lost some of the type safety that you'd expect to get. Well, that's what name variant is going to do. With name variant, you can write it in the old style. So as the writer of this method, I use the tuple style and put in all the type information. And then when I'm the writer of this method, now full type checking is in place. So color is strongly typed, the size is strongly typed as an integer, and so on. So full type checking is going to occur for me as the writer. And what's going to, because I've got name variant on there, in fact, what it's going to do is produce that map version for me. And that's kind of the code that you're going to see happening there. That'll be added in automatically. And I could actually use that visibility options, and I could make the tuple version of ChooseBox make that private if I wanted to. So I can actually make it look like I did a map version. But as the writer of that method, everything's type checked. And Also, what you'll notice, some meta information is actually being stored as part of the new generated method. So that meta information is telling me that in fact color is of type color and size is of type integer. So now, even as the user of the new method, I'm now actually going to get static type information preserved. So in fact, now as the user of this code, it'll also tell me about the information. Now that we've added some stuff in for the type checker, they're the areas that you can see coming up on the screen there. IntelliJ, I think, does a little bit of stuff with this. I can't remember now, but Eclipse and IntelliJ it's still in infancy supporting this feature. So you'll see more and more of this capability over time. And we're retrofitting some of the methods that are a part of the GDK to have this named param information in there. So you'll have improved IDE support for this style of programming as well in the GDK. Another feature that was in 2.5, and I'm not going to spend time going through details, was macros. And I've talked about these AST transforms. This is a little bit of code that you typically write if you were writing one of those AST transforms. You might return a new return statement with inside that you're passing a new constructor call expression. So these are data types that the compiler knows about method nodes, class nodes, constructor call expressions, and so on. If you are writing an AST transform, you need to know about this. Using them, you don't need to know it, but to write one, you used to have to need to know it. Now, with the macros, you don't need to know all that. You just go macro, return a new date, and that'll actually generate all the stuff you see up at the top of the slide automatically for you. There's provision for injecting some stuff you've pre-calculated. So when I've got return new date on this slide here, everything there is going to be generated. But what if part of the expression I've already calculated? So in this case here, I've already calculated the variable expression x, another one y. I'll inject those into the mix by using this special $V syntax here. So it's a very flexible way of writing these AST transforms. And that you can do whole classes as well. I won't go into the details of that. The other thing that's neat is there's a matching process. So yes, it's nice to have the macro generating all the code for you, but do I have to actually, in order to know where in the code I'm wanting to put this new generated bit of functionality, do I actually have to still dive in and know all these AST transform or the compiler data types to find where in the code I'm going to put this? Well, using the matcher, you just write a bit of code and you ask, you can have a visitor pattern that finds any code in the abstract syntax tree that's been parsed that matches that particular pattern. Then you can have placeholders. So what that means is you don't need to be a guru to find where you want to inject stuff, and then you don't need to be a guru to generate some code that's going to be injected. So that's all good. And some examples here. We're often asked, can we do better pattern matching type functionality in Groovy? It's actually a small number of lines of code for you to write that functionality yourself using the macro capability. And there's a site you can go to if you're interested in looking at that. Many of you have probably seen the Spock-inspired tabular style format. You can do a do with data in, again, a short number of lines of code using the macro capability. So go and explore those if you're interested in that capability. The other thing that's in 2.5, just to wrap up, there's now full-blown JUnit 5 support. You've probably seen some of these things, parameterized testing and so on, all the different functionality that's in JUnit 5 is supported. But not only that, any framework that builds upon JUnit 5 will now automatically run inside the Groovy console. So on the Spock 2 is JUnit 5 aware, so Spock tests will just automatically run in the Groovy console, and you can just cut and paste them in there as long as the jar's in the class path. They'll just automatically run. There's no special functionality inside the console that's looking for Spock tests. They'll just automatically work. If you're interested in property-based testing, the JQuick library is a nice library for doing product-based testing. And again, you can just cut and paste code that has the JQuick functionality in it, and it'll be automatically recognized and automatically run that as a property-based test. It'll run 100 tests or whatever. In this particular example, automatically generating some strings that you can concatenate together. So that's all nice functionality. There was also improvements in the shell and in the console. Consoles, there was a lot of data scientists wanting to use Groovy a lot more, and one or two of those have asked for new bits of functionality here and there, and you'll see more and more of that sort of appear in different places as well, as we get time to do some of those. There's over 300 new DGM methods in Groovy 2.5. Not going to go into all the details of those, but you can go and look up the change logs or the release notes, and you'll see a few of those. One of the ones I find very useful is one called tap. So if you've used the with statement, you'll know that typically when you use with, whatever the segment of code in the with block returns will be what the whole with statement returns. So in this particular case, I've got a new person and I go with and a first name and last name, that'll be a string. That whole expression will return a string, which is exactly what I'm wanting for this greet method here. In other places, I'm actually wanting the original object is the thing that I want the whole expression to return. So I just go new person, and I've got Betty Boo here. I'm going to go tap known equals true, and that'll return Betty Boo as the thing for the whole expression after running the code that's inside the tap block. And that's the kind of thing you want to do if you're wanting to return the original object. So this particular, the welcome method here needs the original person. Here I can do it all in one go. It just saves you doing that, spreading that across three or more lines. You can do it all in one go, and the nice thing about the tap is that you can it can pipe on you can go dot tap this, dot tap that, and the original object just gets passed along, so you can sort of build it up in that way. Okay, there was also some Jaxby functionality, some JSON tweaking, configurability functionality, some new CLI stuff. Go and read all the release notes if you're wanting to see some more of that. Okay, Groovy 3. What were the themes? There's a new parent parser. So the old Antler 2 parser that we've got, the Antler 2 library hasn't been updated since 2006. It's got some limitations and bugs. We wanted to get rid of that for a long time. The parent parser does that. It's all the latest Antler 4 technology, and it's a lot more flexible. It makes it much easier for us to tweak the grammar, which will be good going ahead if we want to make further changes. Okay, part of what we've done again is the catch up with Java scenario again. So there was certain bits and pieces, so things like lambda expressions. The old Antler 2 parser would have struggled to support all that new syntax. The new parser makes it relatively easy for us to do that, so we can catch up with all of that, as well as do some new stuff. You can think of it as playing catch up, or you could think of it as, we're going to simulate any Java code that any Java functionality that you want. We can do it in Groovy as well. So whatever tickles your fancy there, you can think how you can think of that functionality. Improved module support. I've talked briefly about that in an earlier roadmap slide, but a little bit more coming up. And some new documentation options. Okay, so these are now just a few slides that are going to whiz through some of the syntax. I don't want to spend too long on some of the functionality that's here. This is the do while loop, and basically the Antler 2 parser look ahead was not as flexible as we'd like, and it was difficult for it to look ahead and determine that this is a do while rather than a do close So do taking a closure as a parameter. And the limitations of the old parser made this difficult to support. The new one has a much smarter way of doing a look ahead and so on in the Antler 4 parser. So supporting this kind of thing is much more feasible. And so we do support it. Lets you cut and paste this sort of thing. Don't use do while very often, but if you do, we try to make things so that you can support anything that Java's gotten. So that's covered off now. The traditional style for loop, the classic for loop in Java we've supported, but not the comma version. So the classic for loop has some initialization steps, a semicolon, a condition that gets tested for each loop iteration, and then another semicolon, and then the increment clauses. We've supported that, but not with a comma separating multiple expressions on either side. Now that's supported. We have always supported the for loop. We've had multi-assignment for a long period of time, but not inside a for loop, and now that's supported as well. We have ruled out particular Java style array initialization options, basically because the curly braces is what delimits closures in Groovy. And so how do I know that I'm not trying to have a closure at that point in the code? The old parser made it difficult to do enough smart looking around at the code to make that determination. Now we know that if there's an array specification in front of it, we know that it can't be a closure at that point, so we can cover off this. There is still the old style is still supported. Some of the Java style array initializers are supported, some are not. Some would still be ambiguous, so you can't do all of them, but there's more that you can do now. There's identity operators. So we've always had this. We've taken over the double equals to call the equals method, and identity or reference equality, we had the is operator to handle that. We've now got the triple equals or the not double equals negated version as a shorthand for those. So some nice short syntax there. There's a not instance of and a not in. Again, minor tweaks, but can make some code look a bit nicer. There's an Elvis assignment shorthand. So the Elvis operator already shortens the ternary operator, and Elvis assignment shrinks it even further, gets rid of the bit of duplication on left and right hand sides. If you were, so here I've got name equals name, Elvis operator hydrogen. Name is obviously appearing on both sides, which is a little bit of duplication there. The Elvis assignment operator gets rid of that as well. A minor tweak, but certainly in certain kinds of DSLs, it's a very nice thing to have. The safe indexing, so we've had the safe, question mark dot, will, if the left-hand side, the object reference is null, the whole expression would return null. We've now got the same thing if the array is null and you put the question mark there, that'll be a safe indexing. The try with the resources is supported. So Groovy often has better ways of doing this. We'll see an example of that, but if you want to go try and specify some resources and then have a block of code, as long as those resources implement auto-closable, which they're going to, with the byte array output streams will, then they'll be automatically closed at the end of that block. Okay, and there's different versions of that. There's a new Java 9 version as well, where you can have the resource declared ahead of the try clause, and all of those different things are supported. But just remember, Groovy's probably got nicer ways. So with closable there, for instance, is one of the things that Groovy supports in its GDK. Often that'll be a nicer way to do things than using the try with resources anyway, but if you want to use that syntax, and it's certainly handy sometimes, then it's now supported. Nested blocks. So if I just start an arbitrary curly brace in my code in Java, that creates a new nested block. And again, because of the potential ambiguity with closures. We didn't support this, but now in a place where a closure can't be, you can just start a new curly brace, put a block of code, and it'll know, oh, it can't be a closure at this point. I can just have a new nested block, and that'll let you redeclare variables and things like that with a new scope. So if I've got a variable A in some sort of outer scope, create a new curly block, I can have a different A inside that curly block, and it'll cease to exist once the block is finished. So again, not used very often, but it's supported in Java, so now supported. We support it as well. The var keyword for local variables and Lambda parameters is now supported. And the big ticket item, Lambda expressions. So Groovy, since I think 2 or something, has allowed you to put closures on all the JDK8 stream methods and so on. You can now use the exact same syntax that Java would use, and all the different shapes are there, so you can have with and without types when it's appropriate, with and without curly braces if you've only got single expressions. You can put curly braces there if you've got statements instead of expressions. You can have, there's a no argument case and so on. Groovy offers a tiny little bit of extra value add in that we can have default parameters the same way you'd expect in closure definitions or method declarations. You can do that as well in the version that we support. Method closures. So the ampersand operator has been available for a long time, and if there's a table there with 2 rows of 2 columns, if I look at the static method with class target, I've got an asHex method there, which is what I'm doing is I'm going to the integer class and I'm looking at its 2 hex string method, and I'm saying return that to me as a method closure, a method pointer, if you like. And I can use that as if it was a closure. And so I can now call the asHex method, pass in 10, and it'll return the hex value, hex digit for 10, which will be A. And I could pass that around anywhere where I'd expect a closure. So that's all good. There was so I could do that for static methods and for instance methods, for instance target, and for a class target. Didn't really make a lot of sense to support the instance method and the class target. You'll get a message with an exception if you had done that. Well, now we actually we allow you to fill in that part of the column there. And this is to align it with the double colon syntax of that Java supports for its method references. So in fact, both these tables now have got identical functionality, but with the double colon instead of the dot ampersand. So if you're familiar with what Java would be doing here, Groovy will now do the same for both the dot ampersand and the double colon. But there's a slight thing that's interesting that you should be aware of. And I thought I had it. There's the table. The table's not coming up for a few slides. I'll talk about how all that pans out with compile static in a minute. But at this stage, you need to know that the double colon is supported and the dot ampersand is supported, and it means the same thing at a conceptual level. And there's so here's some examples of that, using it with streams. You can have using it with constructors and including multi-dimensional arrays. You can do it with your own classes and their constructors. And now the bit I want to talk about very briefly is that's implemented as the double colon is implemented as method references. So the dot ampersand that we saw before for normal dynamic Groovy. Okay. The nice thing about that is I can use big integer colon add, and then I can use all of Groovy's closure methods on that. I can go .curry, .memwise, and so on with that method reference, which you wouldn't be able to do in Java. The flip side is that Java would have a more efficient representation. can represent that more directly in the bytecode. And as it turns out, what we do is if you've got code that's we're compiling statically, we will give you the same native implementation that Java would give you. So if you want to have the highly efficient implementation, put your references inside a compile static block, and you get the same as what Java would give you, but you won't be able to use the .curry, .memwise, and all of those. So you can either have efficiency or you can have the flexibility, and we give you that option. And it's using the Lambda Meta Factory sort of stuff, which if you're familiar with bytecode, you'll know what that's all about. But basically, there's your little code there. If you want to have the fully native one, use compile static and the double colon. If you want to have method closures, all the other columns will be applicable for you. So that's a nice thing to know about. Okay, there's default methods in interfaces. There's getting rid of all your illegal access warnings. So that's really nice. And split packaging. So all of the packages that are in Groovy have now been retweaked. And our original plan some 2 years ago was that Groovy 3 would be fully module compliant. Well, we've taken a little step back from that. We thought the impact on the community would be quite large. So in fact, in Groovy 3, there is both the newly named versions of everything that's fully compliant with split packages, the split package requirement, as well as all the original classes, and they're deprecated. So go and read the release notes of Groovy 3 if you're wanting to make your stuff compliant. You'll have the whole lifespan of Groovy 3, over which time to convert all your code to make use of the new classes. Once Groovy 4 comes in, we'll then be, and we're expecting to do alphas of that in the next few, over the next coming weeks. We'll have our first alpha of Groovy 4, and it will have all of the deprecated ones removed. So it'll be our first version that's going to be fully module compliant. Okay, and so that you can go through all the release notes to do that. Groovy Doc, there's some new features. You'll be able to, you can read the Groovy Doc information during that AST compilation process. In the AST, that information is available, and you can do this new /*:, and Groovy Doc information will appear embedded in your class files if you're wanting to supply it that way. So runtime embedding of documentation is now an option as well. Okay, I've not got a lot of time left, so I've got 2 slides on Groovy 4. So as I said, in a few weeks' time, once there'll be a release candidate of Groovy 3, and we're expecting Groovy 3 not to be too much longer after that. I was hoping to have it out before this talk, but I had to switch over to getting the talk ready, so I didn't quite get it finished. The release candidate of 3 will be out, and the alphas of 4 will be coming out shortly thereafter. And what's the themes of 4? A lot of consolidation. So at the moment, there's different kinds of, there's all that split package stuff. So by the time we get to Groovy 4, there'll just be one version of everything, and it'll all be in the right spot. At the moment, we've got indie. When you have the indie feature turned on, you've got indie invoke dynamic flavored bytecode. There's the classic flavored bytecode. There's int optimization bytecode. There's some other optimizations in the bytecode as well. And obviously, when you've got compile static, it's different bytecode. So there's quite a few different flavors of bytecode that get generated. It'll all be consolidated right down in Groovy 4. There's some feature interaction that occurs between transforms themselves, between transforms and traits, between transforms and joint compiler. We're not saying we're going to have that completely solved, but we've got some known steps that we can take that'll allow us to progress quite a bit of that. And so we've got some plans in place to progress that forward. So that'll be a really, really nice bit of functionality to round out how all of that works together. There's further JDK 9 and 10 module support plan. So things like writing the module info in a module info.groovy file, There's all these things that are on the planning list. If you want to help us get any of that done, please get in touch with the project. We're looking at stream-based XML sweepers, SQL querying, JSON, stream-based JSON querying, and so on. Groovy integrated query, some improvements in the type checker. There's some places where we know it needs a little bit of tender love and care, a bit of tweaking. We'll be looking at that, as well as some potentially some improved type checker extensions built in, things like non-null and so on. We've got some ideas there that we're progressing, so we'll see how that works. Some pattern matching, potentially improvements to make things compatible with the Graal VM, JDK12 switches, for instance. The new string format might be another thing that's on the card. So there's quite a few things that we'll look at. Briefly show you what the Groovy integrated query is all about. This is experimental. We're hoping this will be in 4, but we've got a lot of work to do, and we're wanting a lot of feedback before we progress things. But you'll be able to have expressions similar to the language integrated query that's in C#, as you can see up the top there. And that just, it's not some new language that's invented out of the that we have to sort of do all the right coding for. It's that just maps down into this normal string-based calls that you're probably starting to get familiar with, and there's some C# code there that would show how C# gets integrated. We'll have something similar to that. I haven't shown any code there I don't want to preempt what the JEP is that's working in that space. So anyway, it's exciting stuff that's on the cards for Groovy 4. Lots still to do, so we welcome anyone who wants to help or wants to discuss which things they think they should go in for. Please bring those suggestions to the mailing list. Okay, well that's all the time I've got. Please get back in touch, either Twitter, mailing lists, contact us, however you need to get in touch. Okay, thanks very much for your time, everyone.
Thanks so much, Paul. Thank you so much for tuning in for today's webinar.